some studies showed that it got worse, and some studies showed that it got better, but not a large number compared to some of the other processes that you might adopt. So we'll look into that a bit as well. And also, just from an anecdotal perspective, um, Agile is something that's kind of been adopted industry wide now. I see it everywhere I go. Everyone is doing Agile, everyone is doing Scrum, it seems. But very few teams are practicing test driven development or enforcing test driven development. Usually they'll say, oh, yeah, that sounds like a good idea. You should do that. But the team's not actually going to mandate that or require it in any way. So let's go ahead and look at what it is, and we'll get around to why it might not be so popular or successful after we go through what it is. Um, so why give this presentation? Well, the people who do practice test-driven development claim it can improve design, test coverage, and development efficiency. There's some um, notable people, not myself in this list, not notable, but notable people that claim it's a really good thing. But as I mentioned, the coverage is low, so let's explore that. And before we explore it, we really kind of have to understand what it is. So let's skip that slide because it was a mistake. All right. Test-driven development is a process. I mean, and part of the confusion is that when people talk about test-driven development, they talk about a lot of different things. But there is a formal process named test-driven development. It was come up with originally in a research paper and put out there, and there's rules about how you write your code. It's very similar to um, Scrum in a way, where there's a fairly well defined set of steps that you have to go through. Um, so it gets conflated a lot with just the concept in general of writing unit tests. And actually, if we go look at the Wikipedia, we can see that, you know, uh, keep the unit small. This is again talking about unit testing, test structure. There's a whole section here on really just how to write unit tests, the setup, execution, validation, and cleanup. This is all unit testing. Um, Best practices are again unit testing best practices. So problem though is test-driven development is not just writing unit tests. It really doesn't have anything specifically to do with writing unit tests. One thing it is writing tests before you write your code. Retrospective design over foresight design. Um, Iterative design is another word for retrospective design. Emergent design. The idea is that instead of sitting down and designing everything up front, which is your kind of more traditional waterfall approach, it's a much more agile process where you're going to design things in pieces. And you're going to fix up your design and clean up your design as you go on. It isn't maintaining 100% test coverage or trying to get 100% test coverage. It's not test first waterfall. What I mean by that is you don't sit down and write out all the tests for your release and then go build your release and then run all your tests. Um, so that's not the idea. Test-driven development is much smaller process, about one test at a time, and we'll see that when we go through the practice. It's also not zero design. Um, so because test-driven development happens to have one of the smallest sort of iterative cycles, any kind of agile process, you're going to go through these iterative cycles where you say, I want to add a little bit of functionality, and then you go add that bit of functionality. You say, I want to add another small piece of functionality. Well, test-driven development sort of takes that to the extreme. And some people can think that means that you don't ever do any design, and that's not true. It's just you're always doing your design kind of looking backwards of, oh, I'm starting to get a lot of duplicated code. I need to clean this up and fix my design somewhere. So let's go ahead and look at the actual process itself. Um, I stole this picture from Wikipedia. Step one, write your test. So this is, again, the whole test-driven, test first. The idea here is the first thing you're going to do is write your test. Then you check whether the test fails. Well, when they say write the test, they mean write the test before you've written any code. So at this step, it should fail. When you're just getting started, you write your test, check whether it fails, it better fail. Then you go and you write only enough code. And if your test is still failing, you keep doing that until the test succeeds. And then you go into this refactoring phase where you kind of say, okay, all my tests are passing, so, or maybe all my tests aren't passing. Maybe when I wrote my code here, I got that test passing, but I broke some other tests. So I need to go through, fix the tests that are failing, come back here. Once all my tests are passing, then I can say, okay, do I need to refactor? Is this design working? Do I need to change something? And if so, go ahead and do that refactoring. And then we jump back, and every time we do refactoring, we want to make sure that we check and make sure all the tests succeed. And eventually, all the tests are passing. I feel kind of confident that the code looks good. So instead of going this way, we're going to say, oh, the code quality satisfies. So we'll go back here, we start all the way over, and we write the next test. This test-driven development is really the formal process is, write a test, run it, write your code, clean up, write your next test, clean up, write your next test, clean up. And you get into these very small cycles where each cycle you're just satisfying one test case. So let's go ahead and do an example, and bear with me. Writing code live should be interesting. But everyone's favorite dumb simple example, we're going to do the calculator. To make it a little bit more interesting, we're going to say it's a calculator that supports Polish notation, is what they call it. There may be another word for it, I don't know. But instead of saying 5, press the plus button, press the 3 button, press the enter or equals button or something like that, and you get 8. It's you press the 5 button, you press the 3 button, and then you press the plus button, and it'll add the last 2 things you've popped onto the stack, is kind of how it's conceptually thought of. So let's go ahead and jump down here. We'll make our project for our calculator, make our project for our tests. Oh, wrong project. All right, so we've got a project for our tests. We've got a project for our code itself. Now, .NET Core has generated this class1.cs, which we don't need, and that would be breaking the rules anyway because that's some code that we've written before we've written our first test. So we'll write our calculator tests. I'm not necessarily going to do this very formally or perfectly. Calculator tests. All right, we'll put this TTD calculator for our namespace. All right, and so when they say write the test first, one obvious problem, and this is, according to some people, the correct way to do it, is you're going to get compile errors, and you just say that's okay. So we'll define our calculator here. And IDEs do not like it when you write code this way. So say, well, it should add two numbers. And again, remember it is our Polish notation, so we have a push operation. We'll do it this way. Operation will be some enum we create. Okay, so we've written our first test. Now we can obviously think of a lot of other tests that we could have, multiplying, adding more than two numbers, but we're just going to write one test, and then we're going to go and implement that test. So we need a calculator. All right, and let's see. We need to be able to push into this calculator and then run our execute. So we need execute. We want to go ahead and return the result. We'll also push the result. Execute operation. Needed operation enum. Obviously, I'm probably going to need multiply, subtract, divide. Maybe an enum won't be the best way to go about this in the long run, but we're doing test-driven development, so we only write the code for what we need. So we'll just make this enum with one thing, add. Okay, so let's see, push. We're going to need to push our two numbers. If you've written a calculator like this before, you know this is probably not the best way to go about it, but I'm doing this a little bit interestingly, just to show an example. Okay, so we'll just store it. No, that's right. Okay. All right. Maybe not the best way to write that, but we read it. I cannot spell, huh? All right. Compiles now, so let's go ahead and run it. And our test passed. So now we can go ahead and add our next test. And we're going to say it should be able to add three numbers because we're going to quickly run into a problem with our previous, actually this would be 13 because it's just going to add these two. And then it should push that into the stack. So if we call add right away again, it'll add that 13 with the 5 and we should get 18. So, I mean, this is going to be obviously fail, but we'll go ahead and run it. So we're following the rules. Fails, more than two operand set. So now we go here, and now we could say, okay, we just need to write what we need to write to get this to test. Let's throw an op3 on here. But we're going to look at this and we'll say, you know what, this design is not working. we should be able to have infinitely many operands pushed onto the stack, well, until we run out of memory. So we need some kind of structure, and we look up how we're supposed to write these calculators. We'll see that the structure you're really supposed to use is a stack. We're not just supposed to store them into variables here. So this is kind of as we're going and writing that test, we're always going to go back and refactor, revise our design. So let's say, okay, so forget that. We'll do a stack of doubles, brands. So now this becomes much simpler. Execute. So let's say if operands.count less than 2 insufficient operands. And actually, I'm going to throw this into another method. Operation. And this design, again, will probably fail sometime down the road if we have operations that don't always take 2 operands, for example. 1 equals operands.pop. And we want to push that result back onto our stack and return it. All right, so now we go back here and run all tests. Two tests passed, so we're ready to add the next test, and the next test, and the next test, and so on and so on. And every time we add tests, we're going to go back and we'll probably have to refactor this. We'll have to refactor this in the future, probably to support operands. Like if we have a negate operation, that only takes 1 operand. So this would fail pretty quickly. So then operation might eventually have to evolve into its own class. And then when it becomes its own class, it could say, well, this is how many operands I need, and have a way that it executes. It's no longer just an enum. There might need to be some kind of enum mapping to that class, though. We don't have to worry about all of that. We don't have to design all of that because we're just going to do it one step at a time. So when we go to implement negate, then we have to worry about that and come up with that design as we go about it. So that's our simple toy example. We already had some flaws. So as you could see, I already went through this once to practice, so I kind of knew what to write. So you didn't see it as awkward as before, where the IDE was constantly trying to autocomplete stuff that I didn't want, because it's not really built for writing tests before you write your actual source code. One potential solution, and this is typically what I do in a sense, is I just kind of write down my tests on paper first. Then I go ahead and I implement the code, and then I write the tests in the IDE. Um, you get essentially the same benefits. There's no practical advantage to having that test written in the IDE as something that fails to compile. Um, Missing test coverage. So one flaw you can get into when you're adding a test, going back and writing, adding tests, going back and writing, is you're doing all of this thinking from a black box perspective. Um, as you're creating your tests, this is all black box testing. And what I mean by that is you're thinking, okay, this is my calculator. This is what I expect my calculator to do. You're not thinking about the implementation of the calculator at all. And so you end up missing, if we actually look at this implementation, then this is definitely a test case here where someone calls execute and there's not 2 operands. We can very quickly tell from our white box analysis looking at the actual implementation that we're missing some coverage. We don't have any coverage to ensure that this throws an exception if you don't have enough operands. And so if you're just doing a black box mentality for coming up with your test, you can often not think up of tests for certain exceptional cases, and so on. Um, and that's just, yeah, test-driven development advocates would argue that not all of your tests should come from the test-driven development process. It's just a way of designing, a way of tackling this. So the real solution here is that you should just also have your normal testing process of, after you've written any code, go and make sure that you have enough unit tests for that code. And again, we could easily have known ahead of time that that first implementation was going to be flawed. Uh, I did it intentionally to sort of show how that refactoring phase works. By no means is that the proper way to um, follow test-driven development. If you know up front that you're writing a calculator and you're going to have this stack data structure, don't write it a stupid way just so that you can force that refactoring. Um, and there's sort of this idea. I've seen one or two people that kind of think it's clever or funny, where they can say, "Oh, I'm just writing my first test here, or my first test for some new capability. I can implement this in a very dumb, easy way, which I know isn't going to work, but I have to do it that way so I can follow the strict test-driven development philosophy." Um, I would argue that's not the case. There's no real point in just beating yourself up like that. And we'll get back to this in general, but this whole idea of iterative design, one unit test at a time, I don't think is the greatest way to go about it. Um, so just some flaws that I went through, and even that simple example, this is a fairly hard thing to get right. And so let's talk about, if we do get it right, what are the oh, actually, and that was a simple case. So let's talk about a more complex case. So now um, imagine that we're going to create a web-based calculator that stored that calculator memory in a database. By calculator memory, when you hit the memory store or whatever, um, so we'll just say that our web-based thing is going to store that in a database for some reason, just to make sure that, if we go and open our calculator on a different browser or refresh our page, that data is going to be persistent. Um, and so the problem we run into right away is, how do we tackle test-driven development in this? There's going to be a lot of unit tests, and we want to avoid those problems that I just described. Um, and there's going to be things that aren't unit tests as well. We need integration tests. We need end-to-end tests. Um, you may even have manual tests, hopefully not very many. So the answer here is also kind of the answer of, how do you just in general test a large application like this? And so I'd say you kind of tackle it with these hierarchical tests. And I saw, doing a little bit of research for this before I went, there's at least one article talking about this, where you have acceptance tests, and then you go through each of your acceptance tests and you dive in, and then you go through your unit tests. But we don't really need to define, again, sort of like the onion thing. It doesn't really matter how many layers of tests you have, but we'll start at the top. So we want to build this thing. First thing we would do, again, we're going to write it down. We're not going to write this test, but we'll write down that we need an end-to-end test for add. So we're going to open the page, we'll click the 3 button, we'll click the 5 button, we click the plus button, and it should see 8. So now, test-driven development, we would need to go write the code for this. And we're going to kind of recurse as we go down smaller and smaller. And so we say, okay, well, let's first design how we're going to implement that test. So we come up with our design for that test, and we know, well, that design is going to need new methods on our API. So in order to add a new method or API, we're probably going to want an API integration test. So we'll look at, and maybe that integration test is, oh, I need a push API to push a number into the calculator. And so we would write that push API test. I'm going to make a post call to operands URL or something like that. And so we write that test down, and then we go and we design how we're going to implement that. And then we're going to say, oh, well, I'm going to need such and such a controller. And so maybe now you're getting to the point where you can start writing your unit tests. You say, okay, I need to build such and such a controller, so I have my requirements. So I write unit test number 1, And once you've written unit test number one, then you can go and you can implement that unit test, go through your test-driven development cycle as you do each of your unit tests until you have that controller done. And then you look at the next piece that you'd have to add, write your unit tests, implement that. And eventually you have all the pieces you need for your integration test to run and pass. And so then you say, okay, now I'm going to need another API to get this end-to-end test satisfied. And so you just kind of go through in a depth first search sort of way, and you implement this large feature that's fairly complex. It has a number of tests across a number of different layers, and you get the whole thing running. Um, and so that would be test-driven development in a more realistic case. We're not all just going to be writing simple class library calculators, hopefully. Otherwise, no one's going to ever write any interesting code again. So, what are the benefits of all of this? I'm going to briefly cover the benefits, but there's a huge problem. And so then I'll talk about the problem before we talk about the benefits in a bit more detail. So the benefits that you'll find for this if you look out there is high coverage is sort of an obvious one. If you're writing your tests first, you are going to have tests. Having a lot of tests is a good thing because then you can easily refactor. All your tests run. Notice before when I added this stack, I can be confident that I didn't break the case where I'm adding two numbers because I had a test for that and it passed. And so refactoring, is the art of going through and modifying your existing code into a better design. With test-driven development, you're going to be refactoring constantly. If you're going to refactor, you want to have a bunch of automated tests that can make sure that you're not breaking things. With a simple calculator like this, we were able to refactor without too much fear. When you have a large application that has, a couple hundred classes, and you take some class that's used, in a lot of different places, and you have to make a change to it, that can be pretty terrifying if you don't have a suite of automated tests. Iterative design, which was kind of a fact before, is praised as a benefit. And this is sort of the agile philosophy in general, which is that if you're doing this sort of iterative design, you reduce the upfront investment. You're not going to have to sit down and do a big upfront design. Again, that might be a good thing. So why are we saying this is a good thing? It's been shown just that if you're doing it in this iterative fashion, you tend to only write the code that you need. Um, you end up writing less code, and you can be a lot more responsive to changes or clarifications. Um, and I'll talk more about that later on. Test first, spec first. Um, that's not two different things. That's just two different ways of saying the same thing. But and that's sort of our idea here that we're going to write our tests before we write the code. And again, that was sort of a fact before, and now I'm claiming it's an advantage. So why? Um, and it's the idea that if you think about your tests first, think about what I need to do, then you tend to come up with a better design. You can easily fall into a trap when you're just throwing code out there, and you say, "Oh, um, I need some new functions so I can do this. I need some new functions so I can do that," and you just start writing a bunch of code. Is you can fall into this trap where you design more poorly. It's hard to explain, but if you think about the interface that you want to write, you think in a black box fashion, here's what I need, then it can be easier to come up with a better design for it. It's sort of like in GUI design. If you're going to make a GUI, if you sit down and draw your GUI or write it up front, it becomes a lot easier to actually create the GUI that you want. Whereas if you just start throwing things onto a page, then you often just end up evolving into a sort of a garbage design. So you want to think about what you're creating first before you actually go and start creating it. Um, so let's talk about this problem. We're all going to go watch this video of this person that can hammer nails very quickly, which will be relevant for my example here. So we can see he can just very quickly throw nails in there. This is not what it looks like when I hammer nails. I do not hammer nails very often, and so when I do, I will hold the nail in my fingers and I will take very timid, very soft little hammers, just sort of a tip, 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 a very slow process. And so if I were in a conversation with this guy who can hammer nails very quickly, and I were to ask him for advice, he might say, "Oh, well, why are you doing all of these slow, soft little hammer taps first? That's all just wasted effort, wasted energy. That's going to slow you down. You hold the nail, and then you slam into that nail as hard as you can." Well, if I were to take that advice, the results would be fairly obvious. I would end up just smashing my fingers over and over and over again. And so with test-driven development advocates, you often see the exact same kind of conversation. From a hammering perspective, it would seem kind of silly if I were to ask for advice and their answer was, "We'll just hammer more quickly, just hammer full force, just go for it." That's a kind of a silly conversation. But I see this all the time. If you talk to someone who does test-driven development, is talking to someone who tried it maybe and it didn't work. They're usually saying, I tried test-driven development, and then I ended up with a whole bunch of tests that were brittle and flaky. Go to the next slide so I can read from my prompts. They're slow. I couldn't, I'm supposed to be able to refactor easily because I have this giant load of tests and I can't refactor it all because anytime I make even a small change, half my tests break. I've got like 20% of tests that are failing often anyway. And so then the test-driven development expert's answer is always just, well, those are bad tests. Don't write bad tests. Or, you know, you can't test this design. This is a terrible design. Why did you write this design? Um, and so when I was researching this, I came up some articles. First, I wanted to verify my assumptions that the adoption rate was low, and found one article. I should have saved the link to it, but it's called. I can probably find it. Yeah, so a fairly recent article, um, and here he's going kind of what I just described, which is what would we expect? Let's take the TD workflow and remove the third step, the refactoring step. What would we expect to happen? And it's kind of what I described. You have lots of tests, tests are brittle, blah, 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 blah. And so his conclusion here is that basically, if you're not good at iterative design, if you're not good at um, this kind of constant refactoring, if you don't come up with a good design, it can be very hard to unit test something that's not well designed. And then you end up wasting and destroying a lot of your time um, with these just bad and inefficient unit tests. And so basically, if you don't have all the skills and you force yourself to follow one aspect without having the practice to follow the other aspects, then you can end up wasting a lot of time writing all of these tests, which are just smashing your fingers because you can't write good tests for the kind of design that you have. And then you will come walking away from that with just a really bad experience in test-driven design. And so the conclusion there was that, you can look at the benefits of test-driven design, that's fine, but just kind of following it dogmatically um, and assuming that things are going to go well is not necessarily the case. And just like the hammering example, if you hammer over and over and over again and you practice and you do lots and lots of roofs, then eventually your initial strikes are going to become more confident and faster, and you will get faster at hammering. And then you won't be taking those small, little, tepid initial strikes that you had before. Test-driven development is kind of the same way. If you practice and you write a lot of code and you go through these processes and you just keep trying to improve, constantly improving, then you'll find you're getting most of the benefits anyway. You might not even be following test-driven development, the process, but you're getting the benefits. It looks kind of the same. And so let's talk about, those benefits and how that might happen. Because another part of the problem with test-driven development is that a lot of the benefits from test-driven development, the things we covered here, have little to do with test-driven development necessarily, the process, and more just benefits of agile development practices, modern development practices. For example, high coverage. Um, there's no reason that you could write your code first and not have high coverage. So agile and waterfall both say you're going to need a robust suite of unit tests. Particularly with Agile, if you've ever done the Scrum process, um, you come up with a story, and before you can mark that story complete, you need to have all your tests written and passing and running. Does that mean you have to run your tests first? No. But Agile very much, and Scrum in particular, very much requires that you have that high coverage and that robust suite of unit tests. Um, so there's nothing, this benefit is not unique to test-driven development. If you follow an agile process, or if you just follow a good process, you're going to have a high coverage. Iterative design, that's not waterfall, but that is definitely agile. Any kind of agile process is all about iterative design. Um, and actually, I would argue that they do it in a more useful way. So if you look at the test-driven development example, where you're doing one unit test, go write the code, one unit test, go write the code. You have these super, super small micro iterations. Um, whereas again, if you look at, so I'll pick Scrum as an example because it's the agile process I know best. It's still iterative design, but the way it works is you take one small feature from top to bottom of your application and you go design and implement that feature. So it's not one unit test. You might have 20, 30, 40 unit tests come from just building that one feature. Um, but it's you pick a feature, you design for that feature, and as you're designing, you have that same refactoring cycle where you refactor whatever you need to. So it's the same iterative design and refactoring cycle. It's at a coarser grained resolution. And it's actually very similar to what I was listing here for our complex case. This is basically an agile use case here, which is, as a user, I want to be able to click buttons and add and get eight, it, this is maybe a little bit more specific. In agile use case, you might be covering, I just want to be able to support the add operation, and you have, you know, two or three different things to consider. But this level of iteration, in my experience, tends to be a lot more useful than the super, super micro iteration of test-driven development. But again, you can get this benefit entirely without ever following test-driven development. So then test first, spec first. This is the one that test-driven development advocates will often claim is the primary benefit. And sometimes this is just what people mean when they say test-driven development, which is that you should think about what you're building before you think about how you're going to build it. And so that's not the test-driven development process. The test-driven development process is a very specific process of writing code. Yet this is the what I would say is the key takeaway, the real thing that you should take away from the test-driven development process. And I think is what a lot of people, when they argue that test-driven development is a good thing, what they're talking about. And it's just this idea that before you write any code, you should really sit down and think about what your tests are going to look like. What are your classes going to do? What is the purpose of this class? If the purpose of my calculator is to, add numbers in such and such a way, then how how would that interface look? What will that interface be? What are the dependencies this thing is going to take in? Um, where is this going to be used? And so that test first mentality is sort of the key takeaway I would say that you want here is, and again, this isn't strictly test-driven development isn't the only way you can do this. If you're practicing Scrum or extreme programming as part of its life cycle for development has tests first. They wouldn't, extreme programming is not necessarily the same thing as test-driven design, but again, it's the idea that you're first thinking about what tests you're going to need so that you can get a better understanding of what you need to build, and then you go out there and build it. So that's the end. This last slide was again a copy paste error. Um, Hopefully you got something useful out of it. I mean, test-driven development, again, all I can say for the key takeaway is if you're writing your test first, you have this better way of thinking. Um, there's a lot of benefits to any kind of agile design. Test-driven development is one of them. And I wouldn't recommend that anyone really go out and follow this process dogmatically. If you were going to learn a new process, or if you wanted to think about or just learn about processes in general, um, Scrum is an agile process that's much, much gentler. Um, you can, Scrum is vague enough that you can shoehorn waterfall into Scrum, which is, both a bad thing because then you're not really doing an agile process, but a good thing because I think one of the reasons it's been so popular in the industry is it allows the industry to kind of slowly adopt agile up into the point where they're comfortable with it. And um, now a lot more developers are just naturally thinking agile processes anyway, so that's all very good. Um, Hopefully this presentation was useful. Thanks.